Hello and welcome to Mr. Linford's math course. In this discussion, we're going to be continuing our talk about solving rational equations, but in particular, we're going to be using our knowledge of solving rationals to solve application problems. In particular, we're going to focus on the specific application problem of work. Work is not so much in the sense of if you've ever taken a physics course what work is, but really we're going to be talking about the idea of completing tasks. This is a type of problem that you're very likely to see on things like the PSAT and SAT and many other types of standardized tests because it's going to take in a lot of not only our understanding of proportions and our understanding of how to solve rational equations, but really our way of framing a modeling problem. Let's start with our first example. In this problem, Mr. and Mrs. Z are working on painting their back deck. Mr. Z can paint the entire back deck by himself in 4 hours, while Mrs. Z can in 2 hours. Now, if they work together, how long would it take them to paint the entire deck? So, take a minute and let's try to figure out what all is going on here. They're trying to complete a task. They want to paint the back deck. Now, we know that one of them can complete the task in 4 hours, and one of them can complete the task in 2 hours. But then the question is, how long would it take them if they worked together? Okay, what are we trying to find in this problem, I think is the first question that we need to ask ourselves. So we'll say we want to find the time it takes to complete the task together. So we're trying to complete the task together and we want to find time. That's important to figure out what do we need to find in the problem so we know what type of answer to expect. Here we're expecting time. We're expecting to figure out how many hours it would take them when they work together on the task. So let's try to think more about this. If it takes Mr. Z 4 hours and it takes Mrs. Z 2 hours, how long would it take them in total? We need to think about what is the relationship between two people working together or two quantities paired together. Well, let's think about this in terms of rate. Let's say the rate of Mr. Z to complete a task, we said it's going to be 4 hours. So if I set this up as a proportion, I would say that it takes, the completion of one job takes 4 hours. This is kind of like saying if I went 100 miles per 1 hour, my rate would be 100 miles per hour. So we're saying here that Mr. Z can complete one job in 4 hours. So this ratio right here, this proportion, describes his rate of work. Now let's take the rate of Mrs. Z. She can complete the single job in 2 hours. So here's her proportion. Here's her rate of job completion. Well, think about they're each going to be working together. So naturally, we expect them to probably complete this task in a quicker amount of time if they're working together, right? We don't expect it to take 4 hours or more than that. They're working together, so it should be fairly quick. Let's try to construct an equation. We have these proportions. What do we want to do with them? Well, think about what operation is being implied here. We are saying they're working together. They're combining their rate of time, their rate of job completion, I should say. So, what operation does that signify? Well, the idea of working together, combining things, indicates addition. We're saying that if you take the rate at which Mr. Z completes the job and the rate at which Mrs. Z completes the job, together, that gives you the total rate. This tells you how long it would take them to complete the job together, or the rate at which they're both working. So, that's what we're going to try to find. So, let's see what we have here. 1/4 plus 1/2 gives us our total rate of work. Okay, let's try to first add these together. 1/4 and 1/2, well, we should probably turn a half into the same denominator. So I'm going to multiply that by 2/2. So a half I'm going to turn into 2/4, okay? So when we add these together, we get 3/4. That's the rate at which they complete the job together, okay? 3/4. But what does that mean? 3/4 is that saying 3/4 of an hour? Is that 3/4 of the time that one person completes? I'm confused. What does 3/4 mean here? So let's think. 3/4 is the rate of job completion together. Now, remember how these proportions were set up. We had the numerator represented how many jobs was completed, and the denominator represented how many hours it took to finish the job. So in this situation, when we have 3/4, the 3 represents job, and the 4th represents hours. So we might say here that if Mr. and Mrs. Z work together, they can complete 3 jobs in 4 hours. They can complete 3 jobs in 4 hours. What that's pretty much saying is if they work together, if it takes Mr. Z 4 hours to do one job and Mrs. Z 2 hours to do one job, then they can get 3 jobs done in 4 hours. That means they could paint 3 decks in 4 hours. Okay? Well, I guess that kind of helps us. That's kind of weird, right? I didn't really want to know how long it would take them to complete 3 jobs or complete 3 decks. I want to know how long it takes them to paint just a single deck. So let's try to rewrite this information. We have 3 jobs. 3 decks can be painted in 4 hours. But I want to know how long it would take them to complete one job. That's the thing I'm not sure about. So I know for a fact, given their 2 rates, they can get 3 decks painted in 4 hours. But how long would it take them to get 1 deck painted is the question. Well, maybe I could set up this proportion. I know for a fact that they can get this done. So, how long would it take them for 1? Well, if I have 3/4, that should be equivalent to 1 over however long it takes. This is what I'm trying to find. I'm trying to simplify this fraction, 3/4, so that the numerator becomes a 1. That's my goal here. Take 3/4 and somehow get the numerator to be a 1. So let me clear some space and let's try to solve this equation. All right, we said 3/4, we know that's a rate of work completion for them. That's what we have for them working together. I want to simplify that to have a numerator of 1 because I want to know how long does it take to complete that one job. So let's try to solve this equation. We have 3/4 equals 1 over x. Well, we could cross multiply, or we could just clear the fractions. It's the same thing. What's the common denominator between 4 and x? Well, that's just going to be 4x. So I'm going to multiply both sides by 4x. You could also just cross multiply. I'm just kind of doing the long work here to show you what happens. So we end up with 12x over 4 equaling 4x over x. Well, this simplifies to 3x equals 4. Again, that's the same thing you'd get if you cross multiply. Cross multiply is just a shortcut for clearing fractions. So when we divide by 3, we get x equals 4/3, which is 4/3. That's 1 1/3. So as a decimal, that would be 1.333 repeating forever. So what does this mean for us? We have just figured out what x equals. Remind yourselves of the proportion that we had. 3/4 equaling 1 over 1.3 repeating. Before, if Mr. and Mrs. Z work together, we said that it would take them 4 hours to paint 3 decks. All right, that was fine, but I really wanted to know how long would it take them to paint 1 deck. So, solving this equation, we can say to paint 1 deck, it takes them 1.333 repeating hours. So roughly 1 1/3 hours it takes them. So let's write that down. To paint 1 deck together, it takes them about 1.3 hours. So that's 1 1/3 of an hour, roughly. So here is how we're going and we're solving this situation. We are taking the idea that if you want to work together, you are combining your rate of times. We're taking the idea that if you want to work together, we are combining the rate at which it takes you to complete a task. So all we have to do is come up with the rates, okay? Once we know the rate of time that it takes you to complete individual jobs, we can figure out how much it would be in total. What I'd like to do right now is to take a minute and to try to define the formula or a general formula for what we have going on here. All right, let's try to formalize our thinking and to create a formula here. We said that if you have 2 people working together on a task, they each have their own rate of speed for job completion. And that's pretty general. If you've ever worked with someone, one person's usually probably faster at a task than the other. Very rarely do people complete a task in the exact same amount of time. So if they work together on a single task, like they work together to paint a deck, they work together to build a whatever, right? If they in any way work together to complete a singular task, we are going to say that we want to combine their rates. So let's say rate of first person or thing. In the previous example, we worked with people. You could also work with objects. So such as like some examples use like printers, or some examples use things like other types of machinery that are completing tasks. So let's say the rate at which the first person works plus the rate of the second person or thing That's going to give us the total rate. Now remember, we had a particular way of setting up the rate of job completions. We would say that one job can be completed by person one in some amount of time. I'm going to say speed of person one. So speed one here, that just represents how fast did it take the first person to complete the job. And then we had the other rate, which was set up as one job per speed two. So this is how fast it took the second person or thing to complete the job, okay? That gave us the total. We said one job can be completed, I'll call it speed total. The total speed it would take for both of them combined together. Generally speaking, in our previous example, this is what X was. That was the thing we were trying to find, the combined rates, or the combined times it would take. Notice that this here is not the speed of the first person plus the speed of the second person. That is not the total speed, okay? So in the previous example, we said it took one person 4 hours and another person 2 hours. So altogether, it should take them 6 hours to complete the task. That doesn't make sense at all. Why would working together on the same task slow them down? Now, I get, you might say, oh, well, they might interfere with each other, they might distract each other, whatever. That's not really what we're trying to get at here. We're trying to say, assuming they are totally productive and they continuously work at the same rate of speed, why would they slow each other down, right? They would help each other out. So really, it should take them less time to perform the task. So make sure you understand that this is a thing, that we are just not adding the speeds together. Rather, we're solving this general equation. Now, this was a situation where we just had 2 people completing a task. You could have more. You could have 3, 4, 5, etc. So let's take a look at another practice problem, and let's see how we might incorporate multiple people performing a task. All right, during the 6th episode of the 2nd season of The Office, this is the episode entitled The Fight, Michael needs to sign a collection of documents. At the beginning of the episode, Pam comes into his office and she hands him a stack of papers. All he has to do is sign them. But Pam explains to the camera off to the side that this particular day there's a large collection of papers that Michael needs to sign, and he has a tendency to distract himself from the work. So, in this episode, because of a fight that Michael has with Dwight, he ignores his workload. Instead of completing the task, at the end of the day, Michael asks 5 of his coworkers for help signing his name. Again, that's all he has to do. So, while Michael prefers to talk with Dwight and promote him to assistant regional manager, he's having 5 of his coworkers forge his signature. So, with the 5 people working on a task that really couldn't have taken more than 30 minutes each, how long would it take them to sign the papers if they all work together? If you remember in this episode, it's fairly time sensitive that all of these things get signed because they have to get it to the post office by 7 o'clock. And I think by the time Michael asks for their help, it's just about 6 o'clock, roughly. So all of these 5 people need to work together just to sign Michael's name. So let's kind of get some information down that we think might be helpful to us. Here we have 5 people working. We know that 5 people are going to each contribute productively to a task. Now we have the rate of time for each person. It should take each person roughly about 30 minutes if they work individually to sign all of these papers. But here we want to know how long it would take them if they work together. So what do we need to find in this problem? Again, we need to find the time. That's a key thing here. Remember, we're finding a time. We're finding how long it would take them, okay? So we want our answer to be a time value. In particular, I'm thinking of a value of minutes. Now, again, we need to think specifically, what should this time be? Let's set up our example over here. We know that we are going to combine the rate of times for person 1, person 2, person 3, person 4, and person 5 to get the total rate of them working together. Now, it takes each person roughly about 30 minutes if they were working together. And again, I'm kind of guessing on this. So one job can be completed by person 1 in 30 minutes. And we're going to assume that that's pretty standard for everyone. So each person has this 1/30th rate of job completion. Now we want to know altogether what would the time be to complete one job. So we have essentially 5 1/30ths. So we could say, well, let's just take 5 times 1/30, and that's equal to 1 over x. So 5 times 1 over 30 is 1 over 6, and that's equal to 1 over x. You could clear the fraction, or I'm just going to cross multiply, and I'm going to get that x is equal to 6. This is saying that it should take them, if they work together, about 6 minutes to just complete the task. To go through all the paperwork, it should take them about 6 minutes to sign Michael's name to everything. So here, we're using the formula setup to help us figure out what the total time should be if they're working together. Hopefully this idea of work makes sense to you. Again, it's a very common problem that you see on the SAT and other forms of standardized testing. And the big idea here is really realizing that to work together, you really need to combine all the rates of job completion. If you have any questions, please let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.